Welcome to Haxby Shed and part 6 of servicing this Harrison universal milling machine. Now if you've been following this series you probably think I'm going backwards, but actually I had to change the bearings on the table motor. Well, I've ordered the bearings, they haven't arrived yet, and this is why all this is covered up. Now in this video you'll see me fixing the lid for the table gearbox, and you'll see me stripping this down to some degree anyway and checking it and getting it mounted on the machine and giving it a spin. I hope you'll agree that's progress. I know if I don't do it now before I really start using this machine, it won't get done for years. So I hope you find it useful. I've still got these raised blobs back and front, so I've packed this underneath. Use these useful bits of plastic that you always keep and got it about level. So the idea is to machine this surface, well at least the blobs off anyway, and then flip it over and do the other side. Just a scrape to start with. These are machined as far as I can go with the shaper. You can see just a scratch touching that surface there and there. I'll do those now, and then I'll probably just put it on a piece of emery paper and just rub it around on a flat surface, and that's as good as I'll get it. But I will put it on with a bit of silicone. Sorry, my voice is going again. Second side. Right then, finally we're back to ground zero. I squared off all these edges and I gave it a bit of a polish. Now I'm hoping that this will be my template, and I think it can be. The holes are in the right place. I do have some counterbores, but not one as small as this. This is a 3/8 end mill. Well, that's all right. Let's hope I got the holes in the right place. Well, this is just the first one at the moment. I'm just being cautious as usual. It's taken a lot of work to get to this point. So this gearbox still needs a final clean out, some oil in it, the lid putting on and sealing. But repair wise, that's it, and I'm pleased with it. Well, it was worth the final look. I thought I'd got all the bits out, but I found that lurking in the bottom. Now, when that broke, I'm sure somebody knew that went in. Anyway, it doesn't seem to have done any damage. It's best out, though. I've just put a fine bead of silicone around here. Now, if somebody's going to say that silicone dissolves bronze, I don't want to know. I can imagine how with a soft gasket they pull these through. Well, another day. You can see the temperature in here is just about freezing, but my motivation is strong. Between this face now and the underside of this cover catches. I could kind of hit it on, but I don't want to. So I'm just going to use a shaper to take maybe 1/10 thou off this, 1/4 of a millimetre. Just clocking this up to be horizontal now. That's close enough. Just right. Now, I would like to do something with these very inadequate knurled knobs. You can see they've been jammed in the past, somebody's got some nippers on them, taking the knurling off anyway. But the problem is that they are captive. I'd have to unscrew this from this, if I could, without stripping it. Then, outside of this would have to go in the lathe. And then, would that twist off? Because obviously knurling is quite a forceful process. I'll have to think about that, not one for today. So let's check out this table motor and this trip. Good, okay, so it works. But something I've spotted, you need to be really careful with this. It's fine with the table set at 90, but as you swivel this table, can you see that the gearbox casting here hits this corner of the saddle? So there are quite a lot of limitations in the way you can use this. You can't rely on this 100% to stop the table before it crashes into something. Well, I pumped some of the correct grease into the bearings on that table motor, and I'm afraid it started making funny graunching noises. So those bearings are shot. So I won't change them straight away. I'll get the milling machine working first, and that can be a job offline sometime. There's still lots of basic cleaning and servicing to do on that machine, but I'm going to have a break and start looking at this thing. And the first thing I'm going to do is make a cradle for it out of wood so that I can work on it easily, but hopefully something that I'll be able to drop onto the table and that'll help me get this head onto the machine when I want to put it on or change it over. I reckon this is 7 inches diameter. So I've drilled it out. I'll chop out the middle. Maybe I can kind of fly cut it. Don't know yet. I want to assure you that this is absolutely safe. But I would stand back if I were you. I have set a depth stop, so I can't drill into the table. And actually, that drill in the centre, it's more of a masonry drill. If it works, it works. That's all you need to know. Well, I had to swap sides to get the depth, and the alignment wasn't perfect, but it's not bad. I've nearly done. I'm just working on the high spots. There, marked with the oil. We're getting there with it. This will make it a lot easier to fit to the spindle and to work on. It may need a bit of tuning, but that cradle is essentially finished. I think I'll have to cut a couple of V's out of the back here so that this face gets close enough to the body of the machine to mount it on. I've spent about an hour just cleaning this thing up and trying to get all the muck and grease off it. And I can see there's a couple of things that aren't quite right and need servicing. Now I've undone these 3 big nuts here, which should allow this to swivel. But first you have to get this pin out. It's just an indexing pin. When you tighten this nut, it pulls the pin out. But somebody's had a go at it because they've centre popped this end here. And I think if I just keep tightening, I'm just going to end up stripping the threads. So I'm going to try knocking it out. Well, this is a good sign. With this peg out, at least it moves, and it moves quite nicely. The thing about this is, if there's anything wrong with it, it's going to be expensive. Now, these 2 top and bottom bearings here, I can't remember quite how much they are, but they're probably somewhere between 150 and 200 pounds each, I'm guessing. I don't know for certain, but I'm guessing that. At least this should make it lighter. Ooh, that looks nice, doesn't it? This is 1-to-1, by the way. I can tell that because I turn this bit once and this bit goes around once without any further checks. Right, I wonder how much oil there is in it. Well, a reasonable amount actually. It's plenty wet in there and the oil is nice and thick, so it's probably the right oil as well. Well, that's good. But interestingly, this is open to the oil chamber. So if you have this thing upside down, the oil comes out of there, look. Which is a bit weird, isn't it? When you take that pin out, then you can get these T-nuts out, look. Off eBay I bought a pack of 4 1.5 inch long screws. Spot the odd one out. 3/8 Allen, 3/8, 5/16, 3/8. Next day, still about freezing in here. I'm sick of this cold snap. And in the house it's only about 16 or 17 degrees, which is 62, 61 Fahrenheit. But I don't want to turn the heating up anymore because it's so darned expensive. It's not so much the cost, it's the principle. And anyway, wearing finger gloves and a woolly hat in the house is absolutely fine. So, who knew? The one on the left here is 7/16 UNC. The one on the right is 7/16 Whitworth, and what the seller had done was send me 3 of these and 1 of these. So he's responded to say, oops, sorry about that. It's only the 7/16 Whitworth, which has the 5/16 key. Now, when I look in the manual, this milling vertical head should be secured with 7/16 UNC. Now, some of the screws have been cut down. This was an original screw that came with the mill. And you can see it's been cut and it's actually too short. So I think that they've lost the original 4 screws, rummaged around, found the Whitworth. So according to the manual, the lower ones are shorter. Oh, this is still quite heavy, even though it's only half a head. And you've got to get it lined up as well against these pegs. Let's see what we can do. Oh, that's gone on. Right. The advantage of the Whitworth, of course, is that you can use an 8mm key because 5/16 is pretty much 8mm. And we'll put these in here for now. Now that everything's clamped up tight, this is clamped against the face and the drawbar's proper tight. There's no movement at all on that gear. Neither in or out or left to right. That's good. Oh. I'm just measuring from this face to the near edge of the gear, like that. Now, you won't be able to see this, obviously. I can tell you it's 68 because I've just measured it. And let's see. So, that face to this near edge, I think. How are we going to do this? That way, probably. With this. Which is 67 probably. Double checking with this distance here to the underside of this gear here is 66, and the same distance on the machine is 67.5. So there's only 1.5mm displacement in those 2 gears. But interestingly, the position of the gear on the machine is set by the position of the spindle nose, because that gear within the body, the back half of the vertical milling head, is free to move kind of backwards and forwards, and it's just set by the position of the spindle. Anyway, I think 1.5mm difference between the alignment of the 2 gears isn't any sort of problem, is it? Whilst I've got the opportunity, I've just put a couple of notches at the back here that register with these vertical V-ways. So that should hold it spot on, ready to be clamped up against the main body of the mill. And when I'm positioning it, I can be using this and this to get it up into position or to help me lift it off. And if this is then right down at the base, it makes it a much easier lift from kind of, arm length height. I've just spent an hour doing absolutely nothing. I don't know where the time disappears to, cleaning all this up, but this bush was jammed. This tapered peg was jammed in the bush as well. The thread on this tapered peg is damaged, so I need to get a die to sort that out. Just various bits like that. It just sucks up time. Anyway, we'll get this cap off. It's got a grease point on it there, so you would expect this to be full of grease. Ooh. Well, there's no water in it or anything like that. The signs are good. Do you know that grease is like the stuff they put in CV joints? And I'm thinking it might be even better than the stuff that I've bought, even though the stuff I've bought is what it says on the machine plate. So I'm going to leave that alone for now. I will just check the other end if I can get this end off. Not quite sure how to do it. But I'm going to leave well alone unless it needs attention. There's a greasing point on this to my left here, so you'd imagine this is also full of grease. Come on, tap tap. Do you know, this grease is quite runny. Somebody was telling me in a comment about different grease viscosities. I think I'll just put that back on and think about it like the other. I do notice that the grease in this one is different from the one at the top, but neither of them are lacking grease just now. So I'll spend a bit of time just doing a bit of research maybe. It doesn't need to be done now though, that's the point. When this was on the ground, I took this plug out, laid it on its side, no oil came out. So this is pretty dry in here. Going up. About there, I think. Well, that's easier than trying to do it by hand, isn't it? Well, I just wouldn't be able to do it, to be honest. Even with this Cradle, it still takes a bit of shuffling to get this on. I'll tell you what, I've taken the plug out. We can do that. Leave it overnight. See if anything drains out. Good morning. So I've left this to drain overnight. Out of this back section we got this. The oil's very thick, but at least there's a bit there. I can understand how you could lose the oil out of this section, because when this is removed from the machine, if it's placed on the floor on here, there's a hole at the back of this casting and some of the oil could run out. I understand that. But out of this front section we've got a big fat zero. So, you know, maybe the people who spent so much time greasing this machine didn't have any time to oil it. But I'm going to put in some fairly thin oil, run it on idle for a while, drain it out, see what we've got, and then hopefully, if all's okay, I'll put the ISO 220 in there, and I'll put the ISO 220 in here right now. No idea how much to put in this, but it won't be a lot. Well, that was obviously far too much. You really can't see what's going on with this thing. There's no way to get a light behind it. So I'll drain it till this comes to the level here and then just put a fraction more in. In fact, I can probably stop at that. That'll do, won't it? Can you see that sight glass? The level's right. I've got some light gear oil, HS173 80. Well, there's absolutely no chance of pulling up that thick stuff with this. I've probably overfilled this. You really can't see. If the oil was darker, I might have stood a chance, but I think it's probably up here somewhere. I'll put in about 5 to 6 ounces. We're just kind of starting to think about the electrical things, because there's quite a bit of work to do to rewire those inverters to make the original switches work, if I can get that going. But you could see there that that was drawing about 8 amps, 1500 watts, because I had wondered whether I can run this thing actually off a 13 amp plug or whether I needed a 16 amp connector. It's beginning to look like a 13 would be okay. So let's drain this out and see what we got. It's not the cleanest of oil anymore, is it? But mind you, it's got a lot of air bubbles in there, which is what you'd expect, isn't it? Well, that's settled out now, and it is a bit dirty, but it's not terrible, look. This thing, by the way, it came out of the kitchen. It's only calibrated in ounces, so clearly it only works on imperial turkeys. I'll try not to overfill, so we'll start with just 2 ounces this time. Takes its time.